back to the QST YouTube channel. Today we will be recording from the course revision for 5.1.4 till 5.4.1 for the periodic. These are the questions that I'm going to be covering today, and let's start. Given that e of x is equal to integral of 7x times cube root of x dx, what is the value of e of 27 minus e of 8? Let's take this question to a blank page first. 3. They're trying to say, given that e of x is equal to 7x times cube root of x dx, what is the value of e of 27 minus e of 8? Now let's grab this, add to new page, and let's start. So let's first of all add the powers. So 1 plus 1 over 3, because of the cube root, not a square root, is 7x to the 4 over 3. Integral from 8 to 27. And let's integrate. So 7x to the 7 over 3 times 3 over 7. So cancel 7. So 3x to the 7 over 3 from 8 to 27. So what we're gonna do now is 3 into, and then we just substitute x by 27 first, to the power of 7 over 3 minus 3 times 8 to the power of 7 over 3 as well, which should be getting you around, just plug it in. So again, 3 times 27 to the power of 7 over 3 minus 3 times 8 to the power of 7 over 3, which is equal to 6177. Okay. Number 5. Given that w of x is equal to 40x over 2x squared minus 1 squared dx, what is the value of w of 0 minus w of 1? Now let's start. To solve this question, first we need to let u 99% of the time is the thing inside of the brackets without the power. So 2x squared minus 1. So du will just derive it, will be 4x dx. So now we'll have 10 du, because here we have 40x dx and 4x dx, which will just make it 10 du over u squared. Now in my opinion, for this question, it's way easier to do the new limits by substituting, for example, u of 0 in here, which will start off with -1 at the top, and then you substitute 1 here, and then we're gonna bring it down. So 2 times 1 squared, which is 1, minus 1, 2 times 1 squared, which is 2, minus 1 is 1. And then we're gonna integrate as normal. We're gonna get -10 over u from -1 to 1. Then we're gonna simplify. So -10 over, then we're gonna substitute u by -1 minus -10 over 1. So it will be 10 minus -10, which is 10 plus 10, which is 20. let's check the material. So questions 8 and 9. A curve for which the second derivative is equal to 6x minus 24 has a stationary point at 2, 5. Find the equation of the curve. So first, let's find the first derivative by integrating 6x minus 24. So that will get us 3x squared minus 24x. Don't forget the plus c. By the way, guys, there is a high chance that this becomes written part. So please, once you do this, please make sure that you include that it's equal to y prime, which is the first derivative. And then here, they said has a stationary point at 2, 5. Stationary point being the key word. This means when the first derivative is 0, x is 2. So 0 will be equal to 3 times 2 squared minus 24 times 2 plus c. Then you're gonna plug this into the calculator. So 0 is equal to 3 times 2 squared minus 24 times 2 plus c. And then c is equal to 36. So then let's substitute here by 36. And then now to find the equation of the curve, we integrate again. So that will give us x cubed minus 12x squared plus 36x plus c is equal to y. Again here they said 0.25, which means we can use it in this equation right here. So simply we're gonna find c again to find the equation of the curve. So 2 cubed minus 12 times 2 squared, forgot to include the x here, 12 times 2 squared plus 36 times 2 plus c is equal to 5. Then let me plug this into the calculator. 2 cubed minus 12 times 2 squared plus 36 times 2 plus c is equal to 5. And you're gonna get c is equal to negative 27. So here, instead of plus c, it's gonna be minus 27. And then that's part A done. Right here. And then for part B, they just want the x-coordinate of every other stationary point. So which means they want to figure out what makes the second derivative 0 other than 2. Okay, so what we're gonna do is equate this to 0 by doing mod 5 3. So 3x squared minus 24x plus 36. Mod 5 3, you get 6. X is 6. And x is equal to 2. Here we got x is equal to 6, which is what they're looking for. And now they want the nature. So what we're gonna do here is make a table of variation. So 2, 6, y prime, y, then zeros here, and then SOS, since a is positive, we're gonna do positive, negative, positive. So up, down, up. So 2 is a maximum and 6 is a minimum. Now, which question do we have? Again, number 9. This question always comes as grid, and from what I've heard from my math teacher, there are lots of mistakes. So please, please, please focus on this question, because again, there is a high chance that it comes written, and there is like 100% chance it comes computer in the periodic. Given that f of x is equal to 2 over radical x plus 5x to the 4dx, and that the graph passes of y equals to f of x passes through the point 125, find an expression for f of x in terms of x and o only, and use it to find the value of 4. So first of all, what we're gonna do is integrate as normal. So 2 into x to the negative half plus 5x to the 4, then we're gonna integrate. So 2x to the half times 2, because negative half plus 1 is half, and then you take the reciprocal of it to multiply it with the coefficient, so 2 times 2, 4, and then here we're going to do the rule 5x to the 5 over 5, which is x to the 5. And then that means we have 4 radical x plus x to the 5. Now here, plus c, don't forget plus c. It's really important because we will need it now. So first of all, we need to find c. So they said y is 25 when x is 1. So that will help us find c. So 4 plus 1 plus c equals to 25. C is equal to 20. And then we're gonna do the calculations. So since here they want f of 4, so we're just gonna substitute x by 4 plus 20, 4 times radical 4 plus 4 to the 5 plus 20 should be equal to 1052. Now we're finally done with this section, and we're gonna start doing 5.3.2 questions 15 and 16. Okay, perfect, we got right into it. The area of the region enclosed by x squared and negative 5x plus 6 is k over 6, where k is a whole number. No. So first of all, we're gonna need to find intersection points to figure out what are the limits. So x squared plus 5x minus 6. So we are going to get that the limits are x when x is 6 and x is negative 1. So what we're gonna do but before we do that, we're gonna need to substitute a limit between, like a number between these two, to figure out which one's larger, which one's small. So let's take 0. So here, if we substitute x squared by 0, we're gonna get 0. And if we substitute this by 0, we're gonna get 6. So obviously this is gonna be greater. So we're gonna do bigger minus smaller. So from negative 1 to 6, you're gonna do in parentheses negative 5x plus 6 minus x squared and then you're gonna get 343 over 6, which is the answer. Now number 16, which is the last and final question for this video. The region bounded by the x-axis and y is equal to x minus x squared over 2 between 0 and 3 is shaded in the diagram below. The area expressed is as k over 3, then what is the number equal to k? So let me just move this up, this, let's zoom out. Okay, now let's start by figuring out our limits. So from 0 to 2, and then we're going to integrate the function, so x minus x squared over 2. And then here you can clearly see there is an interruption where it intercepts the x-axis and then it goes down, which means that we're going to take either the absolute value and then add, or take the opposite sign of the part that's down, which is basically subtracting them. So minus from 2 to 3, the same exact equation, so x minus x squared over 2, and that will give you 4 over 3, meaning that k is 4. Thank you guys so much for watching this video. We wish you guys the best of luck in your periodics, exam, and CAs.